Okay, let me give you guys some more practice. So given this speed time graph here, work out the distance traveled between, let's say, 1 second and 3 seconds. So in effect, well, whenever you're given the speed time graph, try to visualize this inside your mind. So you've got your acceleration time graph, and then you've got your speed time graph, and then you've got your distance time graph. Whenever you're given one of the graphs to work with, try and visualize these three. So if you're given this speed time graph here, speed time graph, remember that the gradient here represents the acceleration. So the gradient of this, let's say it's 3, then the acceleration here is 3. Okay, and whenever you're given the speed time graph, which is the middle graph here, the area underneath this graph represents the distance traveled. Okay, at the moment I'm just trying to teach you guys the speed time graph, the middle graph. I want you to be really good at the middle graph before I move on to distance or this one here. Okay, so I want you to be really good at this before we move on. So here I've given you the speed time graph. So inside your mind, you should visualize you're looking at the middle graph, which is speed time. So remember, the gradient represents the acceleration. The area underneath the speed time graph represents the distance traveled. So here, just bear. So here, look at this speed time. So you should visualize the middle graph. Now, looking at this here, later on, I will ask you to work out the distance traveled between 1 second and 3 seconds, meaning that you have to work out the area underneath this graph, meaning work out the area of this trapezium here. In the previous video, I showed you a really quick method. Get the height, and then add this height, and then divide it by 2. That will give you the average height of the two, and then just drag it on, times it across. Well, anyway, before you do that, let's analyze this graph, the speed time graph. So the gradient here represents the acceleration. So if you want to know the acceleration at this precise point here, then you would work out the gradient. Well, the gradient, look at this here, it climbs like this. So the gradient here is really, get the height and then divide it by the across. So the height is, six up and 3 across. So the gradient is 6 over 3, which is 2. So the acceleration is 2 meters per second squared. Okay, because that's a gradient at this point here. So the gradient here represents the acceleration. Okay, and then looking at another important point is normally I would give you a graph like this starting at 0. I would normally give you a graph starting at 0 like this and then climb up. What this means is, well, here you are starting at 4. So what that means is, let's say your dad is you're sitting in the car with your dad. When you're looking at the speed time graph, that when you're starting at 4, it means that initially when time equals 0, the speed of the car is already traveling at 4 meters per second squared. So when you have a speed time graph that starts from 0 and then climbs up here, if you start at 0, it means that the car is at rest when t equals 0, and then it speeds up. Okay, but because we're starting at 4, it means that the car, when the car is already going at 4 meters per second at the initial time t equals 0. Okay, so looking at this here, this tells you the speed initially, the initial speed. Now looking at this here, the acceleration is actually 0. Okay, even though the acceleration is 0, don't forget your dad is the car is still going at 10 meters per second, so you're still covering ground. So it's just like this. if you have your speed time graph here, even if you have a graph like this, the speed time graph, you're still traveling over time. So let's say this is 7 seconds. The area underneath the graph represents the distance traveled. So even though it's a flat line, you're still covering ground. Okay, you're still traveling. You're still covering ground. So here the acceleration is zero. Even though the acceleration is zero, you're still traveling, okay? Because you're traveling at 10 meters per second. So you're still traveling, even though the acceleration is zero. Here, the acceleration, you've got, well, the gradient's negative here, okay? The gradient is negative. So what that means is your acceleration is negative. So you've got a negative acceleration. So what that means in real life here, it means that when you're about here, 10 seconds, okay, your dad is applying the brakes. So your dad's decelerating. He's putting his foot on the brakes. So here you've got a negative acceleration, or you can use he's decelerating. The car is decelerating. Okay. So anyway, let's get back to the original point. Work out the distance traveled between 1 second and 3 seconds. So in effect, you want to work out the area of this trapezium here. Okay. Work out this area here. So yeah, press pause and have a go. What is the distance traveled between 1 second and 3 seconds? And use a quick method. Get the height, get this height plus this height. Well, anyway, do whatever you have to do between 1 second and 3 seconds. Press pause and have a go. Okay, so I'm just going to get this height here, and which is 6. Okay, this is 6, and then plus this height here, which is 10. So 6 plus 10 divided by 2. That will give me the average, the middle of the two. So that will be around here. Okay, and then just times it by this distance here, which is 2. Okay, so this plus this will be 16 divided by 2 and then times 2. So basically I can ignore this. So this will be 16. So the area of this trapezium here, the area of this trapezium here is 16. But 16 what? Look at this. This times this. So the unit here is m over s, and then you times s here. So s gets multiplied to the top, meaning this over this. These two will get killed off, leaving you m. So 16m. What's m? M is meters. So when you're given the speed time graph, the distance traveled between 2 and 3 seconds will be 16 meters, not bananas or apples. Meters. Okay.